Hello class, we're about to start our lesson 4.4, the slope of a line. Our objective, we want to find the slope of a line given 2 points in the graph. The meaning of slope is a measure of steepness and measures how rapidly the line rises or falls. It also is also referred to as the rate of change between 2 points. Important points of reflection from section 4.1. In all ordered pairs, the x-coordinate is the first number or input of the ordered pair and tells how many units to move right or left. As we see here, we have our parentheses, we have our x. X is always the first value. Now, the y-coordinate is always the second number or output of the ordered pair and tells how many units to move up or down, which we see here. This will be our second value of our ordered pair. It's always considered to be y. Now, slope can be expressed different ways. We can use the slope formula where we will have y2 minus y1 divided by x2 minus x1. Or we can have rise over run. Or we can have the change in y over the change in x. Now as you see here, I color coordinated this with all of the yellow being all of the changes in y, and all of the red still is dealing with x. Now, however, do you know how to determine which formula is the best to use? If you are given 2 coordinates and asked to find slope m, then you will use the slope formula. This will be the best formula for you to use. Now, what does m equal y2 minus y1 over x2 minus x1 mean? M stands for the measure of the slope. Now, to get the values for y2 minus y1 over x2 minus x1, you need 2 coordinates, which we will have here. We will have 2 coordinates. You notice in this first coordinate we have an x and a y. Second coordinate we have an x and a y. But it says here, read y2 as y sub 2. That's because the 2 is below the letter here. Think y coordinate, second point. So these are our 2 points or our 2 coordinates, but this y sub 2 is the y value in the second coordinate or the second point. Now y1 means y sub 1, which here it says think y coordinate first point. So we look at this first coordinate and that y value will be our y sub 1. And we do the same things for the x's. x2 is really x sub 2. So it's the x in the second coordinate or point, and then the x1 or x sub 1 is the x value in the first coordinate or point. Now we come to our first example. It says here, find the slope of the line through the points 3, 7, and 5, 19. Now if we look here, we have 3, 7. We know that this is the first coordinate, so this will be our x sub 1. The 7 would be our y sub 1. This 5 and 19, they're in the second coordinate or second point. This would be our x2 and our y2, which we see here. Now what we have to do next, we want to input this into the formula. So we would substitute in y sub 2, y sub 1, x sub 2, and x sub 1. And subtract. Now again, remember I told you all this before when we first started this class. Whenever you substitute in a value for a variable, you always put it in parentheses to signify that you substituted. Now, when we see that there's no changes that need to be made, we could drop the parentheses. Now we will have 19 minus 7 over 5 minus 3. 19 minus 7 is 12, and 5 minus 3 is 2. And we know 12 divided by 2 is 6. So in this situation, our answer is m equals 6. Our slope is 6. Now let's try another example. It says find the slope of the line that passes through the points -3, 15 and 4, 13. I've already set up where our x's and y's are signified here or labeled. So we will go back to the formula and we will substitute in the values. Now remember, I told you always put in what you substitute in parentheses. The reason being is usually a lot of people get tripped up when they have minus a negative number. But having that in the parentheses, that lets you know that this minus is not with this -3. So now what we would do is we would drop the parentheses in our numerator, but here this minus -3 will become positive. So that will leave us 13 minus 15 over 4 plus 3. And our final answer would be -2 over 7, and our slope is a -2 over 7. Now we move on to the next slide. We have a few facts here. The first fact, whenever your y values are the same, your slope equals 0. Also, whenever your x values are the same, your slope is undefined. So let's take a look at that. We have 6, 7, and 8, 7, 7, 9, and also 7, 5. If you notice, your y values are the same here, and here your x values are the same. So we still will use the same slope formula, and we will substitute in our values, which we have here. And we know we will have 7 minus 7 is 0, 8 minus 6 is 2. And over here we will have 5 minus 9 over 7 minus 7, which will give us a -4 over 0, which we know 0 over 2 is 0, and -4 over 0 is undefined. So again, remember, if your y values are the same and your coordinates or if your y values are the same, then that means that your slope will be 0. If your x values are the same, that means that your slope will be undefined. Now, we will look at finding the slope from a graphical display. Just like a book, slopes of lines are read from left to right. The value of the slope is determined by what the y value is doing as you go to the right. So we will start at the left. We'll look at these lines. We're going to look from the left and go to the right and look at what y is doing. So we start here. Starting from the left, going to the right, you notice that this line is going up as far as the y value is concerned. So this is a positive slope, and it's rising to the right. Now we come to the next line here. If you notice, this line is going down when it comes to your y values. This is a negative slope, and it falls to the right. Next, if you notice here, we have a horizontal line. Whenever you have a horizontal line, that means that your y value basically stays the same. So it's a 0 slope. Now finally, we have a vertical line which just goes straight up and down. And your y value basically is, basically everything remains. Your x value stays the same. And that is an undefined slope. Again, with that vertical line, your x value stays the same, and that's an undefined slope. Now, another way of looking at slopes graphically is as such. Now we come here, we see our positive slope. Let's think of this as riding a bike. When you're riding up or you're moving up in life, that's always looked on as a positive, like it's shown here. They're riding up from left to right, that's a positive slope. Now we come here to our negative slope. We'll use the same bike rider, but this time the bike rider is going down. And we know going down in life is considered to be negative, as we see here. Now, we come here. We have our 0 slope, which is our horizontal line, using the same bike rider. Now, if you just ride horizontally, you're basically not moving up, you're not going down, you're basically at 0. You are moving straight across, just like we have here. Now, we go here to our vertical line. Now, we know this is an undefined slope, but you know with riding a bike, whether you're riding up or down, there is no way that you can ride a bike straight up or straight down without falling or anything like that. So we know that that is impossible. And that is our undefined slope. So if you remember these, it will be easy for you to tell whether your slope is positive, negative, zero, or undefined. Now, if you are given a graph of at least 2 defined points and asked to find the slope of a line, then you should use rise over run. Typically, rise over run is much easier to do than the regular slope formula that we were looking at. And is also considered to be another slope formula that you can use. Okay, next, it says determine the slope of the line. We're given this graph here. Now, the one thing that you need to do whenever you're doing graphing and you're trying to use rise over run, you should always get an exact point, not decimals. Don't get decimals, try and get exact points. And if you look here, we have an exact point here and an exact point here. Now, we have other points as well, but those two stuck out to me. Now, it says use 2 of them and apply rise over run. You can use any of these 2 points, any of these 4 points, but 2 of them. Now, so we're choosing to use these, so we could do the rise. If we go from this point to this point, we will rise 2, because from here to here is 1, from here to here is 2. Now we're going to run. Now, if you notice, we're running to the left. Whenever you run to the left, it's always negative. But if you ran to the right, or your point is to the right, it would be positive. And the same thing goes for your rise. If your rise is going down, then it would be negative. So our rise here is 2, our run is negative 1. So we will put that in this formula here. Our rise is 2, our run is negative 1, so our slope is negative 2. Now the line is decreasing from left to right, as you see here, and our slope is negative. Now determine the slope of the line. Let's take a look here. We have 2 exact points here that we're given. We have 6, 0, and negative 3, negative 6. Now I would be inclined here, because it's graphing, I would do the rise over run. So we will rise, and if you notice here, rising from this point to where the other point is here, we rose 1, 2, 3, 4, 5, 6. So our rise is 6. Now we want to do our run. We will go 1, 2, well, let me get the line here. We will go 1, 2, 3, 4, 5, 6, 7, 8, 9. So our run is 9. So now we will have our slope is equal to, we know that the rise is 6 and the run is 9. But we know we cannot leave this fraction in this manner here, because it can be simplified. So we would divide the numerator and denominator by 3 and gives us 2/3. Now the line is increasing from left to right, as you see here. The y value is increasing from left to right, so the slope is positive. And you notice our answer is positive as well. Now it says, what is the slope of a horizontal line? Now, if you notice here, we did cover this before. Remember the bike rider. This is a horizontal line. What did we determine when the bike rider was on the horizontal line? Yes, the line doesn't rise, and we know that the slope is 0, or 0 over x using algebra. Our slope is 0. Now, one other very important thing is this here. Your x value can never be 0. X cannot equal 0, because 0 over 0 is indeterminate, and we would not deal with that situation. Okay, now, again, all horizontal lines have a slope of 0. So we move on to the next slide. It says, what is the slope of a vertical line? We went over that before. Remember the bike rider, riding up or down. You know that we don't have a run, and so we know that this will give us a value over 0, which will be undefined. And of course, x cannot equal 0. And remember, all vertical lines have an undefined slope. Now we move on to the next slide. It says determining the slope of a graph using the slope formula. When using the slope formula with the graph, you must pick 2 points on the line and then use the formula. When using rate of change or rise over run, when given 2 points, you must plot the points and connect them with the line, and then use rise over run. Basically, what's going to happen here is we did exclusively the situation where we got 2 points, we will use the slope formula. Then when we had the graph, we will use rise over run. What we're about to do is this here. We're about to use the slope formula when given a graph, and then we can also apply the rise over run when we just have 2 points. So let's go here. It says find the slope using this slope formula. Okay, now we have these points here. So now we have the value of both of these points, which is -3, -6, and 6, 0. So we can plot those points into this graph here. Into this equation here. You just have to figure out which one you want to be the first and which one you want to be the second coordinate. It really doesn't matter. It still will produce the same results. Okay, so our first one would be -3, -6. So we're going from left to right. The second would be 6, 0. So now we substitute. We know we have y sub 2, and then we have y sub 1, subtracted from each other. X sub 2 minus x sub 1. Now we could drop these parentheses, but because we have minus and negative, we know that becomes a plus, and it's in our numerator and denominator. 0 plus 6 is 6, 6 plus 3 is 9. And we simplify that to 2/3 like we did in the previous problem. So our slope here is 2/3. Now we come here, determining the slope using rise over run, we're given 2 points. Now this is just basically, when we're given 2 points, just like we said previously, you put the 2 points on the graph, and then you draw a straight line and connect them, then you could do the rise over run. So we're given the same 2 points, and we're going to compare both methods. Now we plot -3, -6, and we plot 6, 0. This goes in line with what was just previously said about doing the rise over run. You plot the points, and then you graph, which we did here. So now we can do rise over run. So we had m is equal to rise over run. We would do our rise, which we know here is 1, 2, 3, 4, 5, 6. Our rise is 6. And then our run here, we counted before, is 9. So we have 6 9s, which we know simplifies to 2/3. Now, we're going to take these same 2 points and use it in the slope formula. We just substitute in the values like we just did in the previous problem, and we will still wind up with 2/3. So your slope is 2/3. So really it does not matter which one of these you use, you still will end up with the same exact answer. Now we have our real life situation. We always have to relate our math to real life. In 2014, you decide to put $2,000 in your retirement savings account, hoping that one day you will double your money without adding any additional money to the account. In 2024, you have $3,000 in your account. According to this information, what is your rate of change, which is your slope? So now we want to convert this information into ordered pairs. Now remember, the years always goes first and the money goes second. So we have our year, which is 2014, and the money that was put into the account is actually $200.